So we're going to start by checking to see whether these are functions in a table, a graph, and a set of ordered pairs. When we look at a graph to check for functionality, to check if something is a function, we use the vertical line test. So we're going to draw a vertical line through the graph at several different spots, and in each of these spots, the vertical line only crosses the graph one time. So this is a function. When we look at a table, we look at the x values, make sure if there is more than one x value, or if there's a repeat of the x value, that x value can only be paired with one y. And this x value is paired with two different y's, because we have a 3 paired with a -1 and a 3 paired with a -3. So that is not a function. When we look at a set of ordered pairs, again, we look at the x's. If there's a repeat in the x column in the x values, then we check to see what the y values are. In this case, there are no repeats, so this is a function. Number 2, we just have to match the function to the family name. If the variable is part of your exponent, then that is going to be an exponential function, which would be c. Log is just, you can tell it's a logarithmic function because it says log, so that's d. X, f of x equals x is going to be linear because the highest power is 1. And f of x equals 3x squared minus 5 is going to be quadratic because the highest power is 2. The degree is 2. For each function below, find the inverse. So remember to find the inverse, you replace the f of x with y and switch your x and y. And then isolate the y. Okay, so when I have 4 over y, I have to multiply by y, or y over 1, in order to, because y divided by y is 1, so that we say cancels out, the y's cancel out on this side, and I just have a 4. And I have y times x minus 6 on this side. Now the y is going to be isolated by dividing this side by x minus 6. And your inverse is going to be f inverse x equals 4 over x minus 6. Okay, the second one is a quadratic, so we know that for a quadratic, x has to be greater than the x value at your vertex, so x, your domain, has to start at 0. And we're going to switch our x and y. So, and then solve for y. And then, since I still have a 2y squared, I have to divide by 2. So this is, in other words, x over 2 minus 6 over 2. X over 2 minus 6 over 2. Well, the x over 2 can't be reduced, but the 6 over 2 actually simplifies to 3. And then you have y squared on this side. And when you take the square root, you'll have plus or minus square root of x over 2 minus 3, and that's going to be your inverse. And the last one is a linear, so that's already 1 to 1. This is a y, so I change it to x, or switch this to the x and y, and solve for y. To undo that 1/3, I multiply by the reciprocal, so I do that on both sides. So I have 3x plus 3, and this will be a 1, not a 3. That's a 1. The 3's cancel out, and I just have y on this side, so that's my inverse. Okay, for number 4, create a table of values for f of x using the numbers given here. So we've got -2, -1, 0, 1, 2. So I use the f of x that was given, which I didn't put on the screen, so let me find that. It was 3x minus 2. So now if x is -2, I have -6 minus 2, which is -8. Then you get -5, -2, 1, and 4. And you can just put it in your calculator or figure it out by hand. Now to do the inverse table, I would just switch my x and y's. So x f inverse of x would be negative 8, negative 2, negative 5, negative 1, negative 2, 0, 1, 1, and 4, 2. Okay, and that's your answer. This one I needed to find the domain and range, the inverse, the domain and range of the inverse, and graph the function. So the domain and range is going to come from your vertex, which is negative 1, negative 5. So the domain of the function is going to be negative 1 to infinity, and the range is going to be negative 5 to infinity. And I know when I do the inverse, the domain and range are just going to switch. So the domain is going to be negative 5 to infinity, and the range is going to be negative 1 to infinity. The domain and range of the inverse are the range and domain of the function. Okay, so to find the inverse, replace this with y, switch your x and y, and solve for y. So I have x plus 5 equals y plus 1 squared, square root. Now on the right-hand side, the square root and the square, they're inverse operations, so they basically undo each other, and you end up with y plus 1 on the right-hand side. This is plus or minus. Then subtract 1 to isolate the y. We don't subtract the 1 from the radicand, because that is under the radical. So the 1 is going to end up outside the radical. And that's your inverse. Okay, so to graph this, I need a couple points on the function and on the inverse. Oops. Okay, so let's start with a vertex, which was negative 1, negative 5. Go up the x-axis to the next 2 points. So if x is 0, you get negative 4. If x is 1, you get negative 1. So let's plot those. F of x is negative 1, negative 5, 0, negative 4, and 1, negative 1. And the inverse will be negative 5, negative 1, negative 4, 0, and negative 1, 1. Oops, pretty close. Sorry. Okay, so that's your inverse. This is f of x, and then to graph the y equals x, you just go straight down the middle. The next one, you have f of x equals x squared minus 2. The vertex is going to be 0, negative 2, so your domain of f of x is 0 to infinity, and the range of f of x is going to be negative 2 to infinity. And for your inverse, those are just going to be switched. Just switch the domain and range. Okay, then I need to find the inverse. Change that to a y and switch your x and y. Add 2 to both sides. So you get x plus 2 equals y squared. Square root to undo that the square. And you have plus or minus square root of x plus 2 equals your inverse. Make a table of values, starting with the vertex 0, negative 2. Go up the x-axis. 1, if x is 1, 1 squared minus 2 is negative 1. If x is 2, 2 squared minus 2 is 2. So then we can make our graph. So the first graph will be 0, negative 2, 1, negative 1, and 2, 2. That's f of x. The inverse will be negative 2, 0. Just switch your x's and y's. Negative 1, 1, and also 2, 2. And that's f of x, f inverse of x. And then do your line of reflection. Y equals x. Okay, the next problem, we are given a graph of this function, 1/2 x minus 1/2. What I did was I just picked out some points on this graph. So I see there's a point here, which is the point 1, 0. And another point would be right here, and that's the point -3, -2. So I'm just going to look for the reverse of those points on these graphs. 0, 1. So I see 0, 1 on this one. I don't see 0, 1 on any of the other ones, so it's got to be A. Just make sure you've got -2, -3, which you do. So that's your answer. Okay, which of the following tables gives you the graph of this inverse of this function? So again, I'm going to find some points on f of x and just flip them. So I know if x is 0, I can't do that because you can't do the square root of -2. So the lowest x is going to be 2, 0. So your first point should be 0, 2. And the only one that has 0, 2 on it is A. Let's check another one. Let's start with 6. 6 minus 2 is 4. Square root of 4 is 2. So I should have 2, 6 also. And I do. I don't have 2, 6 on any others. So the answer has to be A. The values in the table satisfy g of x. Which of these points down below have to be on the inverse? So it would be the inverse. -73, -4. No, -13, -2. I have +13, -2. That's not on there. And that's not on there. So is it going to be 11, 2 or 32, 3? It's not 32, 3 because that's 32, -3. So it's 11, 2. Okay, and then we've got to find the inverse of this log of this exponential, y equals 8 to the x. So use your b, p, and n. b is 8. P is x, and is y. So we write log base b, which is 8 of n, equals p, and then switch your x and y. So log base 8 of x equals y, and that's your inverse. Number 10, what is the domain of f of x? Equals x squared minus 4, so that it's 1 to 1, basically so that it's invertible. So remember, that's going to be the x value at your vertex. Your vertex is 0, -4. So this is your x value, so your domain would be 0 to infinity. Next problem, what's the inverse of this function? Change that to a y, switch your x and y. And that should be a y. So x minus 1 equals the square root of y minus 2. Square both sides, undo that square root. So you have x minus 1 squared equals y minus 2. Then you'll add 2 to both sides. And your final answer will be x minus 1 squared plus 2. And your domain is going to be 1 to infinity, and your range is going to be 2 to infinity. That would be for the inverse. They'd just be reversed for the function. And then find the inverse of this. Y equals 3 to the x. Again, it's going to be b, p, and n because it's going to be a log. So your base is 3, your power is x, your number is y. So it's going to be log base 3 base b of n equals p, and switch your x and y. Log base 3 of x equals y. The last one, Thomas and his father purchased season tickets to Panthers games. They have to pay a license fee of $1,000 for the 2 seats. So once they split that up, Thomas pays this much per ticket. Depending on how many tickets. X is the number of tickets, P of X is how much money he pays. So to find the inverse, I switch the X and Y. So I have X equals 500 plus 85Y. Subtract 500. X minus 500 equals 85Y. Then you divide by 85. So your inverse is going to be x minus 500 over 85. X represents now the number of the amount of money he pays, and the inverse is the number of tickets. And then if he pays $840, so in other words, if X is $840, how many games? So I'm going to plug X into the inverse function, so 840 minus 500 divided by 85 gives you approximately 4 games.